In this video, we're going to look at a SUVAT constant acceleration question. The question states that a car travels with constant acceleration along a straight road from point A to B. The car leaves point A at rest and arrives t seconds later at point B with a velocity of 14 meters per second. Another car also travels with constant acceleration along the same straight road from A to B, but leaves point A 1 second after the first car from rest. It arrives at point B with a velocity of 24 meters per second at the same time as the first car. Part A asks, what is the value of t? And for part B we're asked, what is the distance between A and B? So first, before we answer the question, let's look at a simulation to get a very rough idea of what's going on. The first car at the top is going to leave point A at rest and arrive at point B t seconds later at a velocity of 14 meters per second. And the second car will leave point A at rest 1 second later and arrive at point B at the same time as the first car with a velocity of 24 meters per second. Okay, so notice that the distance travelled by both cars from A to B is the same. And although the second car leaves 1 second after the first car, they both arrive at point B at the same time t. So now we've got an idea of what's happening, let's make a start at answering part A. So we need to find the value of t, or the time it takes the first car to arrive at point B after leaving point A. And as with all SUVAT type questions, let's make a list of what information we've got. So for the first car, we don't have any information about the distance travelled, and so we can leave this blank. And the question tells us that the initial velocity is at rest, which means it's equal to 0. And the final velocity is 14 meters per second. Now, we haven't been given the acceleration, we've only been told that it's constant, which just means we're able to use the SUVAT equations, and so we can leave this blank. And finally, the question states that the first car completes its journey in t seconds, so we can label time as t. Okay, so now let's do the same for the second car. We don't know the distance, so we can leave this blank. The initial velocity is 0, and the final velocity is 24 meters per second. We don't know the acceleration, so we can leave this blank. And for time, this is going to be a bit different from the first car, because the second car starts its journey 1 second after the first car. So time for the second car is going to be t minus 1. And you can see why it's t minus 1 in this velocity time graph for the two cars. The first car is shown in red and the second car in green. The second car starts 1 second after the first car and finishes at time t seconds, which is the same time as the first car. And as you can see here, the time it takes the second car to complete the journey is t minus 1 seconds. Okay, so for both cars, we have their initial velocity, final velocity, and either a term or an expression for the time taken. So now let's look at the SUVAT equations and see which one we could use. Well, because we don't have acceleration, but do have the initial and final velocities, and want to find time, the s is equal to u plus v divided by 2 multiplied by time is the one we want to choose. And we can use this equation for both of the cars. So substituting the values of u and v for the first car, we get s is equal to 0 plus 14 divided by 2 multiplied by t, which then simplifies to s is equal to 7t. And substituting the values of u and v for the second car gives s is equal to 0 plus 24 divided by 2 multiplied by t minus 1, which then simplifies to s is equal to 12t minus 12. Now, we can't directly find the time with either of these equations because we don't yet know the distance travelled by the cars. But because both cars covered the same distance, we can make the 7t equal to the 12t minus 12. And so this will eliminate the need to know the distance. So we now have 12t minus 12 is equal to 7t. And subtracting the 7t from both sides gives 5t minus 12 is equal to 0. And then adding 12 to both sides gives 5t is equal to 12. And finally, dividing both sides by 5 gives t is equal to 12 over 5, or 2.4 seconds. Okay, so that answers part A. For part B, we need to find the distance between A and B. And because we found the value of t, we can substitute this into equation 1. So we have s is equal to 7 times t, and so s is equal to 7 multiplied by 2.4, which is equal to 16.8 meters. And we can check we get the same result by substituting the value of t into equation 2. And so we have s is equal to 12t minus 12, and so s is equal to 12 multiplied by 2.4 minus 12, which is equal to 16.8 meters, which confirms the distance between A and B is 16.8 meters. Okay, so that's how you answer a SUVAT constant acceleration question. If you found this video useful, please like it and subscribe to my channel where you'll find more A-level maths videos. Thanks for watching.